What are other kinds of applications that you work on at Samsara?
Yeah. The other one you could think about is like efficiency. And like when you think efficiency, the two class of problems that we could maybe talk about. One is like, fuel efficiency. Like fuel is usually one of the biggest spends when for people who have like a lot of vehicles. Like I consistently meet customers who spend north of like $100 million a year just on fuel. That's like a very common thing. So for them, they would talk about like fuel savings in many different dimensions, and like a common one is on like fuel efficiency savings by finding which of your drivers are actually like not driving really well. Are there like mechanical issues on your vehicle? Which one should I prioritize, and how do I drive better fuel efficiency, which could quickly ladder up to like millions of dollars of savings for people, right? And the other use case on the space of fuel, which we've started recently working on, it's an interesting one, is on fuel theft. We actually realized that I think there was a study that I read recently where it was like $130 billion problem in the world where fuel is actually stolen or like siphoned off vehicles, etc. Like fuel is
$130 billion annually, I assume, being
correct.
stolen from vehicles. I had not thought of that leakage.
Yeah, I had not either. Actually, like it was quite interesting. So what happened was we'd heard about this from some specific customers in specific regions where like, the cost of labor was very low and fuel cost is sort of similar globally, right? So there we actually saw more of a spike of this behavior. So one of the challenges all our customers in that space were telling us, like who operate in that region, was like, hey, could you build a good solution for this? And a lot of the solutions out in the field required you have to go buy external sensors, additional sensors, and actually install them into your vehicles, right? So the challenge for us really was like, hey, how do you scale this solution for all classes of vehicles and that can operate globally? Because the problem that you inevitably encounter is these sensors can be very noisy and the variants can be different based upon the vehicle you're driving, right? So there's no one single easy solution here. We originally explored this problem by doing some very simple or heuristic based approaches, like a rolling median as an example, to like smooth out data to find like variance in fuel levels and look for scenarios. But those started immediately, like there were diminishing returns, I would say, like where the lossiness or like the noise was just too much. And effectively, that's like was not a problem that we could solve. So we inevitably had to move down the path of, okay, let's actually look at different techniques here in terms of how do we apply machine learning algorithms. Like actually we do more like a statistical model here where which can actually smooth out the variance and like effectively like improve the hit rate when we find the anomalies in fuel. Interestingly, like we originally did it for that one region, and then we decided, okay, we have all this data and customers globally. Let's actually scale this up and see what's happening. And what we realized is it's not a very regional problem; it's a global problem. So that was quite interesting for us as a learning, just taking the data and like trying to apply it for like a broader variance of customers.